Yeah, then without further ado, I would like to welcome Alex Vieth, who is at Mercury, one of the, I would say, biggest Haskell employers these days, so it's quite interesting, and he's going to talk about making risk decisions. Please take it away.
Okay, thank you. Thanks, Jasper, for the introduction, and hello, ZuriHack. So as Jasper said, yes, I'm working at Mercury. I collaborated on this presentation with Rebecca Skinner, who was supposed to do it, supposed to be deliver it, but she couldn't be here, so I'm standing in. Yeah, Mercury is perhaps the biggest employer of Haskell programmers. We're a financial services company, not a bank. That's important to this presentation, and we use Haskell, as you could probably guess or already know. Also Nix, but that won't be relevant. So the biggest part of Haskell at Mercury is a YSOD persistent web app. That's like biggest in the sense of not just figuratively, like that's the core of our product, but also literally, because it's actually got 13,000 plus modules in a single Cabal package. And again, I'm not like that's relevant. I'm not just boasting. That's just relevant to this presentation. And by the way, we're hiring. So Rebecca and I were on the risk group. What's that all about? This is risk. This is not like hedge fund risk kind of thing. This is more like compliance risk. So even though we're not a bank and we don't have the banking privileges, we've still got a lot of banking-like obligations. Things like know your customer. That's KYC. We have to, make an effort to actually understand who we're serving and to verify it. I mentioned the BSA. That's the Banking Secrecy Act. That's an American law from which many of these obligations come. AML, that means anti-money laundering. We have to do record keeping to engage in anti-money laundering practices. And even beyond laws and regulations, there's also a bit of a self-interested aspect to this. Fraud mitigation. If there's fraud going on at Mercury, either we're losing money or our customers are losing money, or both of us, we're all losing money. It's not good. We need to mitigate that somehow. So we've got, broadly speaking, rules, policies, and they come down from strategists, we call them. These are not Haskell programmers. This is not Haskell code that we're getting. And so our job, our mandate, or mission, is to not only, well, not always, actually implement that stuff in the YSOD persistent web app, but more generally to enable its implementation in a correct way. So to keep things concrete, there's going to be a running example. It's going to be about transaction processing, because I think it's the most obvious one. What does a financial services company do? We're going to be moving money, facilitating transfers. And there's going to be two kind of sub-policies that I'm going to refer to throughout, just to make it interesting, because one would be too few, three would be too many. One of them being restricted locations. These are geographical locations. For example, we may have a policy that wants to flag something for review if it's to a certain region of the world because we think it's higher risk. And another one would be spend limits. As a kind of fraud or money laundering mitigation, we might want to limit our possible exposure by limiting the amount of money that a customer could move. So just two examples that we use in the running. So to start, this is a depiction of us in the beginning, chiseling our Haskell programs. So we have a YSOD web app. We've got policy. We need to integrate them. Well, there's an easy way to do that. I mean, not trying to get too over-engineering. Just go ahead and do it. Am I getting a bug in my... Oh, no. Sorry, I think I have to refresh. Sorry about that. So you do something like this. We have a YSOD handler. And for those of you who aren't familiar with it, this is a monad, handler 4. And I say all the things M here because you have this app monad that can do all sorts of things. It's got lots of configuration. It can do I/O. It's got database connections. That's the context we're in. And this is really part of the product team. This is transaction processing. Okay, so we have unrisk-related things up top, like we're going to insert some models into the database, and that's the product team. Yes?
Could you slightly enlarge the font?
Oh, I could try.
For the people in the back.
All right. It's not enlarging. Sorry. I'll try my best to. Hopefully, it won't be too much of a problem. I wish I had the pointer, by the way. So things to notice here is that, it says there was if, right? We're adding branching basically to processing. That's, in some sense, that's what our mandate is. We need to, run these policies here, like limits for the Acme International Wire, location for it, and based on those results, we're going to change what happens. Okay, so some things to notice about this naive solution. Oh, all right. That's better than nothing. Yes, so one thing to notice about this is that we're dealing with types like this. If you're not familiar with persistent, I call it an ORM, although this is not object-oriented, so it should be like a functional relational mapping, but it's basically an ORM, and it generates types like this. They have these foreign keys or primary keys in them, and they're not really useful unless you can do database reads. And another thing to notice is that risk policy often needs a whole bunch of other things that aren't relevant to processing at all. For example, you don't need to know the complete KYC profile of a customer or of a receiver just to process that transaction, but for us on risk, we do. And so when we're dealing with this wire data type and these foreign keys, well, this is going to have to do some database I/O just to get the information it needs. But that's okay, though, because we're in ESOD handler with all the things, and we can do those database reads. So we did. It works. It's fine. So, right. This makes it look like there's a coupling here between the Acme International Wire Transfer and the policies. And it's called Acme International Wire Transfer because at Mercury, like I said, we're not a bank. We do our banking or provide our services through partner banks. There could be more than one. There is more than one. And they're dynamic in number and nature. They come and go as the business evolves. And each one has a different integration. And that's a product team's integration. That's not our stuff. That's not our code. We don't own it. And what we find is since each one of them has a different way to process, we have to insert our risk stuff into the product team's domain. And we have to somehow use their models to get our data. So there's a bit of a cyclic dependency there. We're not too happy with the situation, of course, and we hope we can do better. So let's just go over 3 crucial points about why we're not happy with this. First thing being, there's some kind of entanglement here, right? The fact that those database models are used as part of policy really blurs the boundary between where does risk policy start, where does the product side of things end. It's not clear, because we are actually calling back into the product team's code to read those database models. So we prefer something more like a proper API. Like they call us, they give us the information, we get back to them with the decision, done. A couple more kind of knock-on effects of that is that it's difficult to really give a generic policy, right? Somewhere there is a core of a generic policy, but you can't tell because of all the database reads. And furthermore, you can't even put this in a library. It has to be in that aforementioned 13,000 plus module ESOD persistent Cabal package, because once you depend on those database models, you're stuck. They have to be there. Furthermore, we're missing a feature here. Auditing, auditability, that's something that's kind of a must for risk and compliance. So you got to keep records. You got to know what your policies decided, what were the inputs, what were the outputs. That's a true feature, but even beyond that, it's also good for testing and debugging, right? It's nice if we can figure out, say, something didn't happen, we thought it should have happened, something didn't get flagged. It's essential that we can easily find out what did the policy say to do, and was that right? Or, was the policy wrong? But if it was right, then it must have been a bug somewhere else. This is the first thing you want to answer, and you need to be able to do it. But we're reading data from the same database that powers a web app, and it's supposed to change. Sometimes it's not even possible to reproduce that policy evaluation because whatever it was reading changed. Not only the data could change, even the whole form could change, right? We have migrations. And so that ad hoc input grabbing is it's problematic. Nevertheless, we needed it. And so certain areas of risk policy would have bespoke implementations. But we prefer to have something that is built in and free, and you get auditing automatically because you're using some system that we don't have at this point. The third thing, and most important to me personally, I think, is that testing was hard. I would say that this style of policy is just untestable. You can write unit tests, but when you want to do that, your inputs have to be in the database, because that policy doesn't take an input, it just uses the database. Or its inputs, I should say, are these record types that have primary keys in them. So in order to test your, say, transaction policy, right, you want to make an input, you have to put that into the database. That database has constraints. Constraints are great for production, not so great for testing, because now you have to insert a whole bunch of other things. Maybe you need a sender entity, which needs an organization, which needs an admin user, and then you find, just to test your policy, you had to insert like 2FA data and passwords and stuff, and it makes everything really, really tedious. And we still do testing, we still write our tests, of course, but it's tedious to write. It leads to, I think, not optimal testing. And furthermore, to kind of hint at where we're going with the ideal of property testing, when you're doing tests like this on a database, it's hard to have confidence in your coverage, right? The whole database is your input set. And even when you do get a failure, figuring out exactly why, well, that's hard too. You have to fire up a PSQL shell and go poking around to understand really what went wrong. So, you probably all are thinking the same thing. I know the answer to this, right? The solution is you should just use pure functions. This should be pure functional. Why not? It's risk policy. Okay. Yeah, seems embarrassingly easy. And it's the idea, it's where we're going, but there's a bit of a twist. But just in case there's any skeptics, we're going to quickly run down why it would help. So pure functions, they're inherently modular. We could put these in a library if they didn't depend on the ESOD persistent types. We would get the generic policies. Oh, sorry, things are being a little laggy. We could use Cabal for all the Cabal things that it's good for, right? It's got Haddocks. It serves as an API kind of signpost, right? What's the API? Look at the Haddocks. Sorry, there's a difference between screens here. Oh, good timing anyway. Would it solve auditability? Yes, because pure function is just inherently auditable. What do? You log the inputs, you log the outputs, and then you want to find out what the rule was, source location, and then something that identifies the Nix derivation of the Cabal project, of the Cabal package. Perfect. And testing? Yeah, I mentioned property testing. Okay, it's lagging behind. I mentioned property testing, and we can actually use it here if we have pure functions. And we get all the great benefits of property testing. It's enjoyable to write them. You're going to write better tests if you have something that is easier and more fun. Furthermore, the audit trail actually dovetails perfectly with this. You've got property testing to generate your inputs, but you also have the audit trail to give you, a kind of a fountain that's ever springing with new data from real-world policy evaluations. And you can use those to, for instance, do back testing or speculative testing, trying to figure out if we tweak this parameter, what would happen next. That's very valuable. And as a final point, I just want to mention that here, even though we're making a web app here, and oftentimes people might think in a web app, bugs are cheap, don't worry, you don't have to invest too much. But in this case, we're dealing with people's money, so bugs can be expensive. High assurance in this case is really worth the investment. Okay, so it's understood and agreed, right? We want pure functional policy. That's what we're after. And, what's the problem then? Just go and do it. Well, the obvious thing, would be to take that entangled thing from earlier, the thing that does the database reads, that has all the things, that is a ESOD handler, and just split it down the middle. Just do a bit of work, factor it into the thing that has, wait for it, the inputs, and the thing that will be left over is, oh man, this is okay, there we go. The thing that will be left over is the product team's kind of data fetch part. So something for locations, it might look like this. We have such a simple input for pure risk policy, and then we get them back together using FMAP. It's simple. It's what we want. And fundamentally, it is what we did, but in an unusual way because of one problem, which is that we've got many queries to define and maintain. So this is what we'd end up having if we did it that way. Remember, there's a bunch of subjects, right? We have the Acme international wire, but there's also domestic wires. There's ACHs, which is the American electronic payment thing. Maybe there's checks. And then maybe there's like 3 other partner banks, and they all have their own integrations and their own payments. So there's a swath of subjects. And then every time we come up with a new policy, just in the risk group, we've got to go and make sure we have queries that get from every subject that's relevant to the policy input that's relevant. And so we're doing that. We're probably going to have to go bother the product team, and we're going to have to communicate with them. It's going to be a little slow. It's going to be annoying. It's going to be even more SQL to write and maintain. These queries are, as we'll see later, basically SQL. Yeah, and writing these things, I mean, we don't want them to proliferate. It's not ideal. What we really have is one query per subject, right? One single source of truth for all of these database reads that risk might need. This would serve as something that's kind of a nexus between product and risk policy. You know, we call these environments. That's the terminology I'm going to use for the rest of this presentation. These big queries that give all the inputs. It would serve as an encapsulation of all that nasty database stuff you don't want to think about. We make new policies. Well, we can just use a pure function from the big type to get the things we need. You know, we add an input. There's going to be an incomplete record construction somewhere. We know exactly what we need to update. The story isn't actually that great in terms of the other side of things. If the model changes on the product team and there's like a new join table, that's not as nice a solution because GHC can't really help with that when you're dealing with Esqueleto, as we'll see. But it's still nice to have just one, like, there's one thing. That's the information about that subject. And if something changes about the database model, that's the only place that you have to update it. That's what we'd like. And we can do that straight up with Esqueleto. So if you're not familiar with Esqueleto, it's kind of in the YSOD persistent suite of tools. And it gives you something that's a lot like SQL, but in Haskell. So it looks like this. I didn't want to write too much because I'm obviously already running out of space on this slide. But it should give you the idea that you're doing joins, you're writing join conditions, you're doing where clauses. And you know, it's really the worst of SQL and the worst of Haskell together. It's not a great programming experience, and we don't want to proliferate this and have massive blobs of Esqueleto code that we have to build and maintain. You know, it doesn't really compose, people would say, right? It's hard to build these out of smaller, reusable pieces. And well, even beyond just that kind of ergonomics issue and maintainability issue, the real killer is it's not an acceptable solution in terms of resource usage. So you suppose we had something like this. It's that single environment for that subject. Every time you want to run any policy for that subject, you have to run this entire query, which might look benign the way it is, because it's not doing that much. But in fact, we'd have way more. There'd be aggregates too, even. We'd have pretty expensive things in terms of database resource usage. And that's loading the production database that's contending with everything else that's using it. And to try and sell this to the rest of Mercury to say, hey, we're just going to do all of this probably unnecessary database I/O. Nobody's going to accept that. That's a hard sell for good reason. It's just, it's not going to fly. So we're kind of stuck. I mean, really what we want is, well, something we're all familiar with. What if there were no database queries involved? What if we could just do this like it were a normal Haskell record, right? You could use a where clause to say all of the data that you want to bring in. And if you don't use it, you don't pay for it, right? We know that doing it this way is, well, we're all familiar with it. We like Haskell partly because it enables this kind of programming. And, well, the performance issues go away too. Like, you don't have to worry about that database load because the caller decides. It seems like, if only we could get this, right? We're so close. Can we do it? Well, yeah, maybe we can actually. We can get something kind of like this. So that query type that I just casually put up on the screen, never explained, That's actually a free monad of Esqueleto selects. And that's all. That's all it does. It doesn't do any I/O, even benign I/O, even like getting the current time, even logging. No I/O exceptions. So as long as we are careful not to allow any query calls to escape some bracket of database connection with I/O, then we could probably just interleave it, suspend it, interleave it like it were not even really I/O. Well, getting a solution like that, how would that look? Well, suppose we had just these three things, right? I mentioned we have to keep those queries within some monadic scope so that they don't like get rewritten or floated out or anything, because we're going to be interleaving something that actually is I/O. Well, we got to keep it restricted. Okay, so we have some monad. We're not sure what it is. Let's call it M. As long as we could do a query, I call that input. We'll see why soon. And if you can make a suspension of any M, and if you could force those suspensions, well, I think that's all you need. It's kind of like a lifting almost of let bindings, but in a way that you can give them a bit of a special meaning. And I just want to highlight as well that force here and suspend, yeah, these are just about the monadic effects of probably a query. They're not about any usual Haskell strictness of weak-head normal form or deep seek or any of that. And so, okay, not thinking too much about it, you get this complex-looking thing, but I will claim and I will try to convince you that this is actually, in a real sense, the dumbest, simplest way to get what we need to start programming these environments. So unfortunately, it's pretty verbose, right? All we've done here is said M is going to be called closure, and we don't want to make any decisions about how it's evaluated. We're just going to take those three functions, input, suspend, force, and assume we have them. So it's in a sense a kind of very verbose, weird-looking free monad, where we say what we want, say what we need, these three functions, and then we make it into a monad, just like a reader. One way to think about this that might make it a little more intuitive is you could consider it kind of like the MTL style, with monad reader, monad state, things like that. What we have here would be monad input, monad suspend, monad force. And when you're done with all the type class desugaring and stuff, you end up with something just like this. Like, you don't see it, obviously, when you're working with the surface syntax, but it will eventually work out to something just like this. But we've just been explicit. Because this way, if you want to change those implementations, you don't have to make a new type and invent a bunch of new type classes. It's just more convenient in a sense. And as we'll see, the generality will pay off. Being able to control those type parameters is important. We're going to see how controlling the input type parameter can give us two sides of what we need, like both things that come together. And we'll see how the var parameter is really useful, and how it's used in a similar way to what Tom was talking about earlier today in the morning talk. It's a bit like the S in STS, as we'll see. So yeah, get into the code block. This is what defining an environment would look like here. So this is to contrast with what I showed in the where clause and what I showed in that SQL query earlier. So this is supposed to be what a where clause would look like now. But since we're concerned with keeping everything in a monadic block, that closure block, the where clause can't actually be syntactically like a Haskell where clause. There still has to be an ordering that you get from the monad. And you'll be calling your suspensions to, you don't have to, you could just evaluate the effects right there. But in this case, we're trying to demonstrate that you might suspend something about the Acme International wire transfer. And then later in your where clause, you might do things that are more generic, but use inputs that are peculiar to that Acme International wire. So the second line, getting some lazy values about an organization using the ORM type of the organization ID from the Acme International wire. Okay, we've just taken a relatively generic thing and applied it to the special case of the Acme International wire. And we've done it all without requiring that you do that I/O right now. So this is, compared to crafting a join, I think it's a lot nicer. It's closer to the where clause style. And if you want to add something new, well, you can just throw some more suspensions in that kind of where clause-like thing, and you're not going to risk breaking anything else, right? Existing stuff isn't using it, it's new. Throw it in there, use it in your policies. Don't risk breaking existing policies by like trying to update a join correctly, which can be pretty error prone, updating SQL queries, that is. But then what's this weird thing at the bottom here? Like you'll see we're giving not only is it a valuation, which hasn't been defined, but why give a total pattern match on some type that we haven't even defined yet? Well, this is a short digression into what this is all about. So it's effectively a product type. It corresponds to the usual thing that you'd be familiar with. But for every one of those fields, you just give a constructor. And then that constructor sets the type parameter to whatever the field would be. And I'm just going to be explicit and write out the correspondence between the two, right? These are, in a sense, the same thing. If you can give a value for every one of the gadet sum constructors, every one of the fields, then you should have the full record, and vice versa. So it's just a kind of a weird roundabout way of writing a normal record. But why do we do it this way? Well, first off, I just want to show you evaluation. It's nothing special. It's just because you can't put that in a closure return type without impredicative types. So there's nothing magic there. It's just a little new type, just to get that out of the way. So why use these gadet sum types, though? Like, what's the point? Why add this weirdness? Well, it's because they have the same kind as a query. So you can just drop that in as the input type for a closure. And when you do that, well, something really great happens. You get something that's a lot more like a pure function. So I've written out here query valuation just for contrast. Remember, the valuation type is just a function from in this case, it would be for all t, query t, maps to, and then I've just put in an IO-like type parameter here. Just the point is just to demonstrate that how you give a valuation, well, you don't have much of an option because query isn't a sum type. You want to get a t from query t, you're going to have to go to some other monad because you're going to need IO. So you can't really do much here, and it doesn't seem very valuable. But when you're dealing with a sum type, one of those gadet sums that fixes its type parameter to something monomorphic in each of the constructors, then you can do pretty useful stuff. You can literally give a value. And so when we apply this to a closure, it's working. It's going to give us pure functional policies. So whenever the input type is one of those gadgets, you really can consider our policy type to be a closure on that input type. Here's an example of just a silly one, just to show you what it looks like. Your inputs have to be formal. They're not lambdas anymore. You're explicitly saying, I want the Acme International wire amount. Okay. And then you're explicitly saying, I want the city location of the receiver. And then you can do whatever pure function you want in there. And that's legitimately a useful policy. I mean, this one's just a toy, but this is the kind of programming that can give you legitimately useful pure functional policies. First of all, because they are pure, you can give a valuation of the inputs and get the output without any side effects. There's nothing here. You're good to go. You can property test that. You can get all the benefits of pure functions that we were talking about earlier. But what's really cool is how you bring it all together. So first of all, you want to map up those policy inputs to those environment inputs, right? In general, we've got these environments that have massive input types. They're returning these in general, just very big. I'll call them big in reference to policies. Typically, policies need very few things. Typically, environments have a lot of things. So you want to run your policy in an environment, you need to map up the input and the output. Well, how do you do that? Just use functional programming. And things look a bit more complicated here. What's a function in this domain? Well, remember, evaluation, that's a function from every one of the G constructors to a closure that can use Fs. So we've said for every single G how to define it using F. And you can also use let bindings out front. So it's like before the lambda, you can bind things using the input F. And after the lambda, for every G, you can also bind things using F inputs. So it really does correspond to a function in this kind of weirder sense, from F to G. And you can compose them, and you can apply them. And writing them out is a little more verbose, but there's nothing effectful here. There's nothing like special here. It's just kind of a more annotated, more souped up function with a dedicated input type instead of a lambda, and this var for suspensions. And so we'll see the fact that the var is the same throughout, like it's the same var on that closure and that closure. So as you compose these functions, the var remains the same. And that's the crucial point that makes this all work. And it's kind of similar, like I said earlier, we'll see it's a bit like the S in ST, right? You keep that S constant throughout all your ST computations. It's like you're saying that you have the same state underneath it all. So same idea at play here. And now that we have all the pieces, running a policy in an environment is nothing more than just applying a closure. So types line up as we would expect. You got your environment. It uses queries to get every one of the gathered inputs. Then you've got your policy that uses all those gathered inputs to get an output. That's probably composed using typical pure functional programming techniques. And you've got a closure. OK. And then you want to run that closure. It's actually like shockingly simple. We haven't actually decided on how evaluation works yet, right? We just had that closure type with all those parametric polymorphic functions. Well, you want to run it now. You just got to give each of them. And this actually isn't far off from the at-most once evaluator that we're using. It's really, it's a bit longer because we're doing a bit more like bells and whistles for auditing and call stack tracing and stuff. But it fundamentally comes down to this. You choose ST. So how do you do the at-most once evaluation for this? Well, you're going to need some kind of, unless you're just unsafe interleaving IO directly, which we're not doing because we want to be a little more safe than that. You need some way to keep track of what's been evaluated and what's not. And kind of obvious, like pretty simple way is just to try, why not just use an stref, right? Just take an stref, put a thunk in there. You want to force it, read it. Is it evaluated yet? OK, you're done. Is it not? Run it. And then update that thunk. Pretty easy. And throughout all this, of course, how you do those effects is a parameter. And all that we require for that, like we're not picking IO here, because you don't actually need IO. And in fact, you won't want IO. You usually want something like a database transaction kind of monad. So all you have to do is say, whatever you have is capable of ST. And this is essentially the evaluator that we're using in production, and it works pretty well. Yeah, I want to highlight as well that I'm really glad that Tom in the morning presentation brought up how ST is, well, he hinted at the fact that it's not really popular, which is, I think it's a shame, criminally underused. It's, in my experience, it's come up reasonably often, and it's always been, well, I'm really glad it's here. It's really pleasant to use, because we could have used an mvar, but we're not doing concurrency, so we don't need that. Could have used an IORef, but we're only doing reads, so it's good that we don't have to commit to that full IO. And so now specializing things, here's what we wanted. You specialize to query, and you have an environment that uses actual database queries. You have a policy that is pure, and now you can run it using actual database. So DB is stand-in for the thing that actually can do all of the database stuff, and it has IO. You can do, ST in it. You can run a query, but it's okay because all of those interleaved queries that might come out of this that use run query DB, they're never going to escape the confines of this DB. It just can't be done. That's you're not going to be able to pass a var back because of the old ST trick. And a final example in this vein is that it's also useful for property testing in a kind of a cool way that I felt worthy for mention on this slide. And the cool thing about it is, okay, not only the fact that it's exactly the same as for queries, but because of the at-most once evaluation, even if you have a massive environment, like I said, they're going to be big in general. If you don't use some of the inputs, they don't affect shrinking, right? So you're going to get better shrinking in general if you use this, because all of the generators in that environment, their whole shrink tree will just disappear and won't be factored in if you don't use that input. So in general, it's going to lead to better tests, which I think is really cool. Okay, so that was a lot of code to take in, and I'm sure the text was too small as well. So let's just go for a quick summary in a different order. So the point is, if you use a gadet sum to represent your policy inputs, as opposed to just using normal Haskell lambdas, right? If you do that weird transformation where instead of a record, you take a gadet with the fields, then you end up with something super useful. Not only can that express your policies that can be evaluated purely and therefore tested, but the same construction, the same closure construction that can express those is also suitable for the other side of things, the environments. If you just don't pick a gadet sum, if you pick a query monad, then it fits right in. It's perfect. It gives us that interface between risk and product that we were in need of from the beginning. Yeah, it's almost like using normal Haskell data structures. Obviously, it's not quite as ergonomic. There's a bit of an overhead, but it's satisfying. It got us where we needed to go. Okay, there we go. Nope. No, that's not yet. Although, feel free to interrupt with a question or comment whenever you want. Okay, here we go. So yeah, just some closing thoughts about what worked well. So yeah, it solves those three main issues, of course, that we wanted. So it's like, baseline meets the needs. Okay, I don't know what's going on here. I'm just gonna ignore it. Another thing is that we found that using these query closures actually has had applications outside of just risk. Applications in which we were able to use the infrastructure of closures and environments to solve a problem that wasn't actually risks. And we ended up with artifacts like library investment, things that we could use on risk, which is really cool. Wasn't expected, but we got it. I really wish that this would actually show up, because, okay. Yeah, we also got another bonus. That gadet sum style was pretty useful when it comes to auditing. So we talked about this feature of auditing. You're going to have this audit log. Okay, well, you need to say how to serialize those inputs, and you need to hopefully give some metadata, right? Things like maybe a documentation string, maybe a pretty printer for your property tests when you want to show a value in an input set. And it's really nice to be able to package all this stuff together and associate it with the inputs just by using a plain old function with a pattern match. I just find it really satisfying. It works really well. So for instance, when you want to write the audit log, you call the audit log info function, and you take the JSON codec, you take the label, and now you can make a whole JSON object of all the inputs. It's very cool. Another bonus, also pretty great. Has-call stack in Haskell leads to a lot of grief. I think a lot of people coming from other languages quite rightly so expect that they might have a call stack when they get an error. But there's good reasons why in Haskell you can't always count on that. And so we have has-call stack, but it's pretty error prone. If you forget to include a has-call stack at the right spot, you risk like losing half your stack. And people see that, they think this is terrible. You can't even get a call stack. What's wrong, Haskell? But in this situation, if you're using closures, I left out a part of the definition because I thought it was just irrelevant. But actually, each one of those functions has a has-call stack. And the evaluator can see all of the source locations of every suspension, every input, every force. And you can opt in to evaluating with a call graph trace. And the programmer doesn't have to do anything. You don't have to remember to put these has-call stack constraints everywhere. You're always going to get a useful call graph. Finally, just a mention of some things that could use more work that aren't like necessarily solved, some pain points. Yeah, the audit log, even though the log itself works, really well. There's also the matter of associating those log items with the product team's stuff, right? There's still the product team out there, and they still have their own models. And sometimes it's not clear exactly which audit log corresponds to whatever their unit of work is. So for example, a transaction processing, there's no automatic way of associating their domain types with our audit log. And I'm not sure if there could be a reasonable generic solution. It's a matter of investigation. UX is always a big one. I mean, you saw these types. They don't look necessarily so simple. They can look daunting. That var type parameter, for example, there's no way to get rid of that. People are going to see that and think, what's this weird thing? I mean, it's true of STS as well, I think, to a certain extent. It's not great, but I mean, I think it has to be there. I can't see a way around it, so, well, maybe there is. It's also kind of a knock-on effect in the API boundaries. So I mentioned how we like to use Cabal for API boundaries. Look at the Cabal exposed modules, look at the Haddocks. But, well, people might not like that API boundary because they're seeing these closure types, and it's a new thing they have to learn. So these are just difficulties about organizational things and of course, training and documentation and getting people accustomed to it. Any questions or comments?
Thank you. This was super cool. As someone who has worked on basically the same tech stack, I don't know, I wish I had this. Could you speak a bit more about the interaction with actual Esquelito from the viewpoint of you wanted that performance improvement, you wanted the laziness of the queries. So what's actually going on then when I'm sort of writing these individual queries for these field selectors? How can I opt into saying, oh, most of the times I want these fields, these always go in the join. Is everything going in the join at the end? Are these things individual parts of a transaction? All of this stuff, basically.
Okay, yeah, great question. The goal is mostly to avoid joins if you can. So the inputs in those closures would be simple primary key lookups for the most part. Sometimes you would do a small join if it makes the most sense. But the pattern that I found is most effective in this is just suspend every single model you have, every one of those persist entities. If you can get to it, if it's relevant, just suspend it because there's no cost in doing so. It's good to have it there. So I don't know if that answers the question. The idea, yeah, if you wouldn't be changing the join, I guess, is what I'm trying to say. You would just be modifying locally one suspension and not having to, deal with all of the difficulties of modifying a join.
Two questions, actually. Function, capital F, is obviously a category, right?
Probably.
Oh, so you haven't... I was going to ask if you tried to extract some abstraction out of this. I was wondering if it was also an arrow, for example. Or...
I think, morally, yes. I'm not sure about kindness, right? This is glitching out again, sorry. I'm not sure if it would be the right kind, like to match the category type class, because is it going to go there? Okay, please stay. Oh. So the type parameters to it are these types of kind type to type. So the F and the G in function, they wouldn't fit in the kind of the instance to category, right? It has to be type to type. Unless they've made it polykinded, I don't think they have.
Okay.
So my answer would be yes, morally these things are categories, but you wouldn't be able to use the usual overloaded. I don't get it. The usual overloaded thing. You'd have to have your own.
Okay, it wouldn't buy you much anyway. I was just wondering. Completely different question, probably at the edge of the scope of what you were talking about. But when I hear risk group, I think of risk as something quantifiable or related to probability. but all the code you've shown is kind of very deterministic. So is there actually something like, in case of this country of origin or something, make it 10% chance to pass this for manual audit?
That we don't, as far as I know, we don't have anything like that. But that would be the way we would do that is to put the kind of the directive with the probability would be the output of the policy, and whoever's responsible to implement that, like that would be ultimately currently out of our purview to be necessarily implementing the result of that decision. Take for analogy, if we say to reject a transaction, we don't necessarily control how that's done. It depends on the particular integration with the particular partner bank. So our job kind of stops at giving a very informative, granular decision about what you should do.
So this feels a little bit like the higher-kinded data pattern, this kind of the style of translating records into functions from GGTs in their fields. I wonder if you've looked at the relationship there or can comment on the...
Sorry, I didn't hear the relationship.
So the higher-kinded data pattern, ranked to classes.
Well, look who's prepared. I wish the slides would work. Okay, let me see if I can... So gathered sums and HKD products. There's a correspondence here. We could have had I've used a tuple as an example, but the idea is you could have had a record where every field has an F parameter on it, right? That's the HKD. That's what HKD means, higher kind of data. And they're the same in a certain sense. But the gadet sums just like they just automatically work. They fit. They have the right kind, and it just worked. It just seemed natural. But in essence, though, I don't think there's anything really preventing one or the other. HKD though does, I don't know. I think it has a perception of being more complicated, at least at Mercury. So we're happy that we could avoid it. Yeah.
So albeit with 13,000 modules, do you ever have long build times, and what have you done to solve that problem, if anything?
We have long build times. So I know Ian Kim is working on that at Mercury, so doing some good work there. But as far as local team efforts, honestly, the best thing that we can do on risk is to avoid ever having to build that that project, that's my plan, and that's why I was so keen on getting this pure functional policy going, because now we have a Cabal package that the massive web app depends upon. And in that Cabal package, it's only got tens of modules. It's really fast to work on. It's like, it's the Haskell iteration cycle. I mean, I know Cabal and GHC aren't the fastest, but it's fast enough to deal with the small module. And so we can do the vast majority of our work in this local package, we call it. And we can do all our property testing, all our development. We can be sure before we go to build the big package that what we're integrating is almost certainly what we want. And then we can minimize the amount of rebuilds we're doing on the huge monolith.
Okay, thanks.
Okay, let's thank the speaker again. Thank you all for another great day at Zurich. I believe the food truck is ready outside. So again, there's only going to be one food truck tonight, so try to spread out a little bit throughout the evening. Fortunately, the weather has cleared up, so maybe we can resume the old Zurich tradition of sitting by the lake and talking Haskell. Thank you all.